In this video, we're going to start Chapter 5, and we're going to start off with reviewing our fundamental trigonometric identities in 5.1 and adding a brand new set of trigonometric identities called the negative angle identities. So just as a review, we learned back in, I think it was Chapter 2, our basic trigonometric identities. We had the reciprocal identities right here, and there were 6 of them. So I've outlined them. Cosine of theta equals 1 over secant of theta, which leads us to secant of theta equals 1 over cosine. Sine equals 1 over cosecant, which leads us to cosecant equals 1 over sine. And then tangent equals 1 over cotangent, which leads us to cotangent equals 1 over tangent. And then we looked at our quotient identities, and we defined tangent as sine of theta over cosine of theta, and cotangent as cosine of theta over sine of theta. And then lastly, we looked at our Pythagorean identities, and we had 3 of them, if you can remember. We had sine squared plus cosine squared equals 1, tangent squared plus 1 equals secant squared, and then 1 plus cotangent squared equals secant squared. So then we're going to take a look at and add to these identities. We're going to add our negative angle identities right here. All right, so these are our new definitions. It says sine of negative theta equals negative sine of theta, cosine of negative theta equals cosine of theta, tangent of negative theta equals negative cotangent of theta. Negative tangent of theta. Cosecant of theta equals negative cosecant of theta. Secant of negative theta equals secant of theta. And tangent of negative theta equals negative tangent of theta. So I really would like you to take a look at this middle one. Okay, these are our oddball ones. All the rest of them, if we take the trigonometric value of a negative angle, we get negative times the trigonometric value of the angle. Okay, even here, right here, we take the trigonometric value of a negative angle, we get negative the trigonometric value of the positive angle. All right, so why is cosine a little bit different? Well, let's take a look at our unit circle. I'm going to draw hopefully a nice circle. All right, so if we move forward with theta, and then we move in an opposite direction, negative theta. Let's just say this is pi over 4, and this is negative pi over 4. So let's just do an example. This is quadrant 1, 2, 3, and 4. And if you remember, we had a little acronym, all students take calculus. So let's take a look at the signs of our angles with respect to our trigonometric values. So if I take a look at the sign of negative pi over 4, well, sine is negative, right? Sine is negative in Q4. But if I take a look at the sign of, here, let's write this out, negative pi over 4, that's going to be a negative value. But if I take a look at the sign of pi over 4, that's going to be a positive value. Okay, so that's why for sine, that's why if you take the sign of a positive angle, it has an opposite sign of if you take it of a negative angle. Okay, so why is cosine a little bit different? Well, let's change this to cosine. If we move in a positive direction and we go positive pi over 4, the cosine is positive. But now if we move in a negative direction, I know cosine in quadrant 4 is also positive. So regardless of whether you move in a positive or negative direction, the cosine of a positive angle is going to have the same sign and the same value of cosine of the negative angle. And that's why the reciprocal functions are the way they are, right? The reciprocal of cosine is secant. So because cosine is positive in both Q1 and Q3, secant's going to be positive in both Q1 and Q3. if I even move further around this, if I move further around our unit circle and move into Q2 and then go backwards into Q3, same thing, cosine is going to be negative in Q2, but also negative in Q3. All right, so why does tangent work the way it does? Well, we know that the tangent in quadrant 1 is positive. So if we take the tangent of positive pi over 4, we get a positive value. But if we move backwards, tangent in Q4 is going to be negative. So they're going to have opposite signs, right? Even if we go into Q2, tangent in Q2 is going to be negative, but tangent in Q3 is going to be positive. So they're going to have opposite signs. Cosine is the only one that's going to keep its sign. Okay, so if you can remember this little oddball section here, then you'll do just fine. Cosine is the one that keeps its sign. Okay, the signs moving forward and the signs moving backwards are equivalent. The other four functions, the signs are opposite. So let's work through a couple of examples that you're going to see on your homework using our identities. So it does say, it says, if cosine equals negative 0.65, then the cosine of negative theta, well, we just went through a little chat about these two being equal. Okay, so if I know the cosine is negative 0.65, I can replace it in my little identity. So I know that cosine of negative theta is going to be negative 0.65. Okay, let's move on to the next one. If cosine of theta is 0.8 and sine of theta is 0.6, now we have to find the tangent. All right, so if I take a look at all of my identities, tangent, how does tangent relate to sine and cosine? Well, I know that, whoops, that was a horrible A, that tangent of theta equals sine of theta over cosine of theta. It's one of my quotient identities. So I'm going to replace sine of theta and cosine of theta with the values that are given. And if I multiply by 10 and reduce, I get 3/4. And if you want to convert that into decimal, you can. It would be an exact decimal. It equals 0.75. And then the last one for this section, it says, if cosine equals negative 1/5, then what is the negative cosine of negative theta? Well, let's write the identity first. I know that cosine of negative theta equals the cosine of theta. But I want you to take a look here. I need to change this identity slightly because I have a negative in front of my cosine of negative theta. So if I multiply this identity by negative 1 on the outside, I get a negative cosine of negative theta equals negative cosine of theta. So now all I have to do is plug in my value for cosine of theta to find out what the negative cosine of negative theta is. Remember, we substitute, right? When we have, when we use parentheses when we substitute. So this is going to be a positive 1/5. All right, so we can manipulate our identities to make them work with the given information. Okay, so here it says find sine of theta given that cosine of theta equals 5/6 and theta is in Q1. So remember, sine has a different sign, S-I-G-N, in different quadrants. It's positive in quadrant 1 and 2, and negative in quadrants 3 and 4. So it's really important to know what quadrant you're working in. Well, how does sine relate to cosine? Well, I know I have a nice Pythagorean identity that looks like this. So I'm going to use this to solve for sine. So I am going to say 5/6 squared plus sine squared equals 1. 25 over 36 plus sine squared equals 1. And when I subtract, I get sine squared equals 11 over 36. So remember, sine is positive in quadrant 1, so when I take the square root, I'm going to use the positive answer. So I'm going to get a positive radical 11 over 6 as an answer. All right, so if we wanted to find sine, given that cotangent is negative 1/3, how would we do that? Well, how does cotangent and sine relate? Well, I know I have a Pythagorean identity that relates cotangent to the reciprocal of sine. So I'm going to use that, because if I solve for cosecant, then I can find sine by taking the reciprocal. So I'm going to plug in the value for cotangent. And when I square that, I get 1/9. And when I add the two, I get 10/9 equals cosecant squared of theta. And when I take the square root of both sides, I am in quadrant 4. So what is the sign of sine? It is negative in quadrant 4. So when I take the square root, I'm going to take the negative answer. So I am going to get, for cosecant of theta, I'm going to get the negative radical 10 over 3. But sine is the reciprocal. So sine is going to be negative 3 over radical 10. But I now need to rationalize. So I get negative 3 radical 10 over 10 for sine. So remember, it's really important to know what sign you're looking for, whether it's positive or negative. All right, so this is the last of this section that I'm going to do. How do I find sine if they give me tangent? All right, so it tells me tangent is a negative value. So that tells me I am in quadrants 2 or 3. Tells me secant, which is the reciprocal of cosine, is positive. Well, secant and cosine are positive in quadrants 1 and 4. Sorry, I had drawn the wrong quadrant here. Tangent is negative in 2 and 4. So this is going to be a quadrant 4 angle, and sine is going to be negative in quadrant 4. All right, so this is going to be a two-step problem. I'm going to use tangent squared theta plus 1 equals secant squared theta, because if I can find secant, I can find cosine, and therefore I can find sine. So I know that tangent is negative radical 7 over 2, and when I square that, I'm going to get 7/4 plus 1 equals secant squared. And now when I combine those, I'm going to get 11/4 equals secant squared. Secant in quadrant 4 is going to be positive, so when I take the square root, I'm going to get a secant that is going to be radical 11 over 2. Okay, so now I know from this information that cosine is 2 over radical, cosine is 2 over radical 11, which I'm not going to rationalize because I'm going to plug it in and square it. So now I'm going to use sine squared plus cosine squared equals 1. Sine squared plus 2 over radical 11 squared equals 1. Sine squared plus 4 over 11 equals 1. So when I subtract, sine squared is going to be 7/11. And now let me erase this so I have room to finish. So when I take the square root, I'm taking the negative.